two-step equations. By the end of this, it's gonna be very easy, so stay focused. Let's start the video. Look at these four equations. 2x plus 2 equals 8. 2 times the group x plus 2 equals 8. X over 2 minus 1 equals 4. And x minus 1 all over 2 equals 4. Here's the strange part. Each pair uses the exact same numbers, and yet each pair is solved in the opposite order. The reason is right here. These parentheses and this fraction bar. One tiny symbol decides everything. So here's the single rule that controls all four. Every two-step equation wraps x inside layers. Here, x is on the inside, and an operation wraps around it on the outside. To solve it, you undo the outermost layer first. And grouping symbols, like parentheses and fraction bars, change which layer is on the outside. Keep that in mind. It's the whole secret. Let's start. 2x plus 2 equals 8. Think of it as a balance scale. On the left, 2 mystery boxes, each one is x and 2 coins. On the right, 8 coins. The scale is perfectly balanced. Which operation is outermost? The plus 2. So we remove 2 coins from both pans. Take 2 off the left and 2 off the right. The scale stays level. Now we have 2x equals 6. Next, split both pans into 2 equal groups and keep just 1 group from each side. 1 box on the left, 3 coins on the right. X equals 3. Let's check. 2 times 3 plus 2 equals 8. 8 equals 8. It works. Subtract first because it was outermost, then divide. Now watch this one. 2 times the group x plus 2 equals 8. Same numbers as before, but look at the parentheses. This time, x plus 2 is locked inside a box, and the whole box is multiplied by 2. Now the times 2 wraps everything, so it's outermost. This time we divide first. Divide both sides by 2, and the wrapper comes off. We're left with x plus 2 equals 4. Now subtract 2 from both sides. X equals 2. Check it. 2 times the group 2 plus 2 equals 8. 8 equals 8. Perfect. This time we divided first, then subtracted. So why the difference? In the first equation, the plus 2 sits outside the times 2, so we undo the plus 2 first. In the second, the plus 2 is trapped inside the parentheses, which makes the times 2 the outer layer, so we undo that first. Same numbers. Opposite first move. The parentheses flip the order completely. Now the fraction family. X over 2 minus 1 equals 4. Picture it as bars. This blue bar is x over 2, half of x. This little red piece is the minus 1. Together they equal the green bar, which is 4. The minus 1 is the outermost layer, so we add 1 to both sides. The red piece fills back in, and the 4 becomes 5. Now x over 2 equals 5. But x over 2 is only half of x. So we multiply both sides by 2 to make a whole x. The half bar doubles into a full bar, and 5 doubles into 10. X equals 10. Check. 10 over 2 minus 1 equals 4. 4 equals 4. Done. Last main equation. X minus 1 all over 2 equals 4. Same pieces as before, but now the minus 1 is trapped inside the fraction bar. Let's solve it as a journey on a number line. We start at 4. The fraction bar groups x minus 1 together, just like parentheses would, so we multiply by 2 first. The dot hops from 4 to 8. Now x minus 1 equals 8. Then add 1 to both sides. The dot moves from 8 to 9. X equals 9. Check. 9 minus 1 over 2 equals 4. 4 equals 4. Beautiful. Same story as before. When the -1 is outside the fraction, we add first. When it's trapped inside the fraction bar, we multiply first. Because a fraction bar groups everything on top exactly like parentheses. So here's the big idea behind all four. When there's no grouping symbol, the plus or minus is outermost, so you undo that first. When there is a grouping symbol, the times or divide is outermost, so you undo that first. One simple instruction covers every case. Spot the operation done last to x and undo it first. Why does this matter? Arithmetic goes forward. Start with 5 times 2 plus 3, you get 13. Algebra runs that backward. Start with 13 minus 3, divide by 2, and you find x. That's the leap. Algebra reverses the chain to find the unknown. 2 superpowers make it work. 1, do the same thing to both sides. 2, undo the operations in reverse order. These two ideas power everything in algebra that comes next. Now it's your turn. 6 questions getting harder. Pause after each one, try it, then watch the solution. 3x plus 1 equals 10. Subtract 1, 3x equals 9. Divide by 3, x equals 3. X over 4 plus 2 equals 5. Subtract 2, x over 4 equals 3. Multiply by 4, x equals 12. 4 times the group x minus 3 equals 20. There's a grouping symbol, so divide by 4 first. X minus 3 equals 5. Add 3, x equals 8. The group x plus 5 over 3 equals 4. The fraction bar groups the top, so multiply by 3 first. X plus 5 equals 12. Subtract 5, x equals 7. 5x minus 7 equals 3x plus 1. Here the x is on both sides, so collect them first. 2x equals 8. Divide by 2, x equals 4. 3 times the group, 2x minus 1 equals 21. Divide by 3, 2x minus 1 equals 7. Add 1, 2x equals 8. Divide by 2, x equals 4. So how many did you get right? Let's bring it all together. 2-step equations. One rule, undo the outermost layer first. Equation 1, x equals 3, subtract first. Equation 2, x equals 2, divide first. The parentheses flipped the order. Equation 3, x equals 10, add first. Equation 4, x equals 9, multiply first. The fraction bar flipped that one too. 4 equations, 4 pictures, a balance scale, a wrapped box, a bar model, and a number line. But always the same idea. Find what was done last and undo it first. Grouping is your signal that the order just flipped. That's 2-step equations.